Good morning. Once again, welcome A-level physics. Topic for today is 1.3 measurement, mainly for practical. Topic 1.1 and 1.2, we look at quantities and unit. Topic 1.3, we look at measurement or the magnitude itself using different instruments and how to estimate the random error, the uncertainty, and then how to combine the errors. Right? After that, we will study about different quantities. Speed of car is 60 kilometer per hour. So we want to know, can we write so many significant figure? And then from topic 2 onwards, we look at how each derived quantity is defined. Okay, so let's get started. Right? For resources, you can go to Facebook. This is Physics AS. And this is you can find my notes and my YouTube material there. Or you can go to Physics Partial Paper AS. This one mainly partial paper, partial paper before 2020. And also for practical physics, practical AS. Okay, you can get a model answer for those before 2020. Okay, let's go to syllabus. As I say, it's important to know the syllabus. The syllabus tell you how much you need to know. And then the other thing you have to do is try the partial question. That will confirm to you what is required by the examiner. Because sometimes it's not easy to interpret the syllabus. So you can study more if you want to, but it won't come out in the exam. Right? That's for your general knowledge. Right? This is Cambridge A-level physics. So we are looking at instrument for measuring some quantities and how to estimate the reading. One measurement, how to estimate the error, or you call it random error, estimating random error, and then rules for combining random error. There we have to multiply, we have to divide, we have to subtract, we have to add. Right? Remember, potholes start from a tiny depression on the surface. If on sand, it disappears after some time. Rain and wind will cover the depression. It becomes bigger as more cars go through it. Then it becomes an incident you will never forget when the pothole is too large. What can we learn from this? To learn physics, it's not by reading. First, you read to understand, or listen to talk to understand, or teachers teaching. You reinforce your understanding by solving problems. Right? Get a good partial paper topic by topic. After every topic, remember to try a partial paper. If got problem, ask a teacher in class. Okay, let us start. Right? This is the first significant figure, second, and this is the third significant figure. We just review what was significant figure. Correct to the nearest significant figure. This one has one significant figure. This is 2, 0, we don't count. We don't count this one. 1. This one also 1. We don't count the 0 before the decimal point. This one 2, because it's written there. Intentionally written there means you can read up to here. So it's 2 significant figure. This one, as I said, we don't count the 0 before the number, but we count it after because you write it down, you include it in because your instrument can read up to here. So it's 1, 2, 3, 3 significant figure. Right? So zeros before a number other than 0 is not counted. The instrument used to measure, in this case, is 4 decimal place, but 3 significant figure. 1.001 has 4 significant figure. If the 0 is between the two number, other than 0, then let's count as 0. This one we are not sure. Cannot be sure. It can be 1, it can be 2. This one we can be sure because it's intentionally written the 0 here. So it's 4 significant figure. Same. 1000, how many significant figure? Then it can be 1, can be 2, can be 3, can be 4. Depend on the instrument that you use. Write carefully to clearly show the number of significant figure. So it's important to write down the number of significant figure you want it to be written. If it's written as that, then the power 3, you don't bother about this one. You count this only 1. Right? Scientific notation. 1.0 is 2. You count this part. Same. 1, 2, 3. 3 significant figure. 1, 2, 3, 4. 4 significant figure. You could count the power. Instrument used determines the number of significant figure. Thus, a length measured using a meter rule should be recorded as 0.9, not meter, not 0.9. That is important. This is especially for your paper 3 practical. That is to the nearest graduation. Right? So this is correct. You are reading for length. This is wrong. The 0 must be there because it tells you you use meter rule, you can measure, you can read up to here. Experiment. Right? We measure 7.5 length, breadth, 2.5 cm. When you write L is 10.5 cm and B is 2.5 cm, then you are using meter rule. Wrong choice of instrument. Large percentage uncertainty. Because uncertainty will be 0.1 here. Uncertainty will be 0.1 here. Right? So very large uncertainty. We try to make the uncertainty as small as possible, about 1% or less. So correct apparatus to use is vernier caliper for matching both of them, so that we can reduce the uncertainty, right, to 1% or less. A rough estimate will tell you that the thickness is 1 millimeter. A micrometer will be used to measure thickness. So for the thickness of this glass slide, we use a micrometer. Right? It's about 1 millimeter. So the best instrument is micrometer. So the choice of instrument is important in your practical. Instrument used determine the number of significant figure. Meter rule, smallest graduation is 0.1. So we just read up to 0.4 cm. Vernier caliper, the smallest graduation is 0.01 cm. So we read to 0.35 cm. Right? Like this part. Then micrometer, the smallest graduation is 0.001 cm. So the measurement can read up to 3 decimal place. Right? So this one will be 3, this is 4, this is 3, so 3.5 there, then we see where they go inside. 3.5, 0.35 cm or 3.5 millimeter. Right? Cannot round it off. You must write to the actual number of significant figure that you measure. Choice of instrument important, so that any measurement is made to make with the acceptable precision. Number of significant figure. Experiment technique must reduce as far as possible any uncertainty in reading. We'll talk about uncertainty later on. For example, which instrument will you use to measure a length of 1 cm? Vernier caliper or micrometer? Measuring our length, 1 cm. Right? You use meter rule. Uncertainty is just 0.1, right, in the measurement. So if we use vernier caliper, it's 0.01 vernier caliper, right? Micrometer would be that. So this is called uncertainty. It's always this one, the last significant figure, or the smallest graduation. Right, let's go, let's try some question. Right, have a go at this partial question. How to read the emitter. The diagram shows the reading of an analog emitter. Which digital emitter reading is the same as the reading on the analog emitter? So this is 5, this is 4, this is 3, this is 2, this is 1. Right? So this is 1. In between there, it will be 5 division. So 1 divided by 5 is 0.2. So each smallest division is 0.2. So it's 1.246, 1.6 milliamp, right? 1.6 milliamp don't have, so you have to convert it to microampere. Right? So 1.6 milliampere, right? Choose the right answer. That's 1,000. Change to microampere. So its answer is A. What is the reading of the stopwatch? Right? 3 minutes, 53.17 seconds. Complete the table with either the appropriate instrument or the quantity measured. So 15 cm, what instrument to use? Right? With the rule. Length of about 4 cm, what instrument to use? Vernier caliper. Diameter of about 1.24 millimeter, what is the appropriate instrument to use? Micrometer. Right? Voltmeter and ammeter for measuring what? A quantity. Resistance. Voltmeter for measuring voltage. If you have ammeter, measuring current. So together, we can calculate the resistance of the wire or component. Spring balance or Newton balance. Newton meter is used for measuring weight. Level balance, measuring mass. Angle is measured by what instrument? Protractor. Time, stopwatch. Frequency of wave, CRO. Cathode ray oscilloscope. How would you measure the diameter of a wire? Right? You need to, if you ask this question, use a micrometer. Wire is very thin, like this one. Measure at a few places along the wire and obtain the mean diameter. Right? That's what you will normally do if it's a wire, because the wire may not be uniform. That's why you may have to measure at different places and then find the mean diameter. Right? For A level, you need to do only 2 or 3 times. That's sufficient. Correct the following measurement to 3 significant figure. Right? The first one, 1, 2, 3. So that one have to 6 round it to 4. Is more than 5. And have a go at this one, B. 9.64. Right? 7 is more than 5, so round it up to 4. Right? Remember, here we don't count as 0. We want to up to here. Okay. It's necessary to add the last 2 zeros. Example for this one. to the above example. Right? Three significant figure, we cannot drop the 6 and the 0. Right? You cannot write it as 7, 8, 4. But we have to write as 7, 8, 4, 0, 0. The 0 must be there. But when we count, it's 1, 2, 3. We don't count the 0. So that the size of the number is still 78,400. Right? You cannot make it smaller. It must be roughly the same size. If the two zeros are not written, then the value is 784, like this case, which is too small. Right? We cannot change the answer when we round off. Right? So standard form, then we can see clearly. When we write in standard form or scientific notation, then we can see more clearly. 1, 2, 3. Yeah? Don't count this one. The two zeros are necessary to be added to maintain the size, but are not significant. That means we don't count that. When the value is written in standard form or scientific notation, then the answer is clearer. So you want me to clearer? Right, in scientific form. Length of a rectangle slab is 20.4 cm. Its width is 4.26 cm and thickness 0.56 millimeter. Calculate the volume. Right, so volume is length and width and thickness. To convert all to cm, calculate out. Right, according to calculator, that's what you get. But we cannot write so many significant figure. Right? So the least significant is this one. 2 only. This is 3. This is 3. The answer should be 4.9 cm cube. Right? So the number of significant figure of the answer or the result of calculation must follow the least significant. This is 2, this is 3. So we follow 2. Okay, we can see that the uncertainty, usually we take the last significant figure for this one, times 100 is 1.7. So your answer cannot be better than that one. Usually in calculating the volume or the final answer, the error is getting worse. Uncertainty is getting worse. Okay. Making graph into a straight line. Have a go at this one. The frequency of oscillation F of a mass suspended from a vertical spring is given by F is 1 over 2 pi K over M, where K is a constant. Which of the following plot will produce a straight line? So we can either rewrite the equation. Right? These are constant. E is 1 over root M. M is the one changing with frequency. So this is your Y equals to mx. So we can plot F against 1 over root M. And this is your gradient. Right? Or we can square it. F squared, this one becomes K, this one becomes square that is 4 pi squared, this one becomes M. And then this becomes your gradient. And then this will become your Y, this becomes your X. That's your choice that the experimenter will have to do. Plot a graph of F squared against 1 over M, or F against 1 over M. So have to see which one is the answer. So in this case, the answer is B. Yeah? Let's go at this one. Light meter measures intensity I of light falling on it. Theory suggests that this varies as the inverse square of distance. Which of the graphs support the theory? Right? This is wrong. It should go parallel to the y-axis. This is wrong because it should be parallel to the d-axis. Right? That's why it's given. Inversely proportional. I is inversely proportional to distance square. So rewrite that. I equals to k1 over d square. Then compare to equation of a straight line. Y equals to, this is your m, this is your x, this is your y. The answer is donkey. It's a straight line. Choose the following and answer the question below. A is which equation? B is which equation? C is which equation? You need to recognize the shape of the graph. Right? So this is your y square over 4x. This is your y equals to x squared. Go this way. These two are parabola. This hyperbola. You need to recognize such graph. Errors and uncertainty. Right? Look at random error. Usually, the constant are tabulated in the handbook of chemistry and physics lesson. That is anywhere you go to university, you want to use it. But for us, we are not interested in that. So we are going to random error, estimating random error, how to combine random error, where we can multiply, divide, add, or subtract. Then we go to systematic error in another video. Effect of errors on graph, these two will be in another video. You won't be interested in sensitivity, it's no more in the syllabus. Okay, some technical problem. Okay, let us look at how to estimate random error for a single measurement. As example, measuring the length of a rod. Right? So we look at that's your part of the meter rule. Let's just read like that. This is in millimeter. So we have 20, 25, 26. So it's between 25 or 26. Right? Example, it's not 25 or 26 millimeter. So I have to estimate the value as 25.5 millimeter, 12.4, 25.6, up to your, we call it uncertainty. So no one is right. And we can try to get as best as, we call it estimate, because it's the best we can do. Error due to observer, or need to estimate the last significant figure. We need to estimate, right? 25, sure. But more than that, we are not certain. You have to estimate the last significant figure. So example, right, in your worksheet 48, let's look at the example there. Determine the acceleration due to gravity. Right? We may have a student measuring acceleration due to gravity given different value. So we estimate the mean first. Right? To find G, we take all the value, add them together, and divide by, there are 2, 4, 6 of them. Okay, the average value is that. So the true value is 9.81. So random error, errors that cause reading to scatter equally about the true value. This is the true value. This is the estimated value. So these are all scattered about the mean value. Values above or below the true value and are not constant. It's not constant. You can see that it's not constant. Every time you measure, it's different. So random error, errors that cause the reading scatter equally about true value. Example, measurement of length of wire, diameter of wire, room temperature. Why? Why do we have random error? Error due to observer. There's a need to estimate the last significant figure. We have no choice but to estimate the last significant figure for one reading, not for a sample. Can we reduce it or eliminate it? Can be reduced by taking more measurement of the quantities, finding the mean of the sample, or by plotting a graph and drawing the line of best fit. Right? So various name, terminology, maximum possible error, uncertainty. So we use Greek alphabet, either the small Greek alphabet or the capital Greek alphabet. Delta. Error is deviation from the correct value. Right? So that we write L plus minus delta L. Delta L is the uncertainty. This is a measurement. So example, if we got 25 plus minus 0.1 cm, means that the true value is between 24, 2.4, and 2.6 cm. Right? That means 2.5 minus 0.1, you get 2.4. 2.5 plus 0.1, get 2.6. Right? For one measurement or single measurement, the smallest gradation. Right? That's how we estimate uncertainty. Go to the smallest gradation of the instrument. Example, in this case, is ruler. So we take initially, right, initial measurement. Here, although we may say it's 0, but we can still argue there's uncertainty there. Right? We don't know whether it's slightly more or slightly less than 0. So that's why we write as 0 plus minus 0.05 cm. Right? We take the smallest gradation, divide by 2. And then here is 2.5. Uncertainty 0.05. So there is your piece of wood. You want to find the length of a piece of wood. Each measurement of the length involves 2 readings. Usually we forget about that. There's one reading here and reading here. Error in reading. That's how we calculate half the smallest gradation. Even when reading graph, in the exam, you are allowed to make a mistake of half the smallest gradation. So in this case, smallest gradation is 0.1. Right? This 1 cm. Is 0.1 cm divided by 2 is 0.05 cm. So to find the length, we take the final reading, is the final reading, minus the initial reading. Okay? We add the two errors together, we get 0.1. So that's why it's not necessary to try to read 0.053 or something like that. We add the absolute error. Absolute, we are interested in the positive answer, this positive value. 0.05 plus 0.05 is 0.1 cm. That's 0.1 cm. Right? So for single measurement, smallest graduation, example meter rule is 0.1 cm. So we write the length as 2.5 plus minus 0.1 cm. And that is called the uncertainty, right, of the random error. and it's always returned to one significant figure only. So the number of significant figure for this value L follows this. If this is one decimal place, this also must be one decimal place. So it tells us that the length is between the length is not a fixed value, not a certain value. It's between 2.4 to 2.6 cm. That's why it means uncertainty. Not sure. Right? It's not a value, not a single measurement. It has uncertainty. There's an error. Uncertainty in measurement is always equal to smallest graduation. That's important to remember. Right? That is your measurement, and that is the smallest graduation. Right? So error in measurement is the smallest graduation. Right? So we don't try to bother to read 2.55 cm. Or we can write as 2.6 plus minus 0.1. So you still include the value there. Right? So we normally don't write it this way. What is wrong with this answer? This one decimal place, this also must also be one decimal place. So the answer should be that. Right? That's taken from the internet. Uncertainty must be to one significant figure. In this case, one decimal place. So that measurement must be to one decimal place. Follow. Right? Absolute, we want the positive value. Proportional, we take delta L. Right? That's uncertainty divided by L. Or fractional error. Percentage, we times 100%. That's my short form. Delta L over L times 100%. Rules for combining error, addition and subtraction. Like example A plus delta A, B plus delta B, these are your measurement. So adding them, the sum A plus B, right? Or A minus B, you just add the absolute uncertainty. So sum of that or different, this one, is just you add these two together. It doesn't matter subtract or divide. It doesn't matter whether you add or subtract. You just add the uncertainty. Because the answer must always, when you do any addition or subtraction of quantities, the error is always getting worse. Cannot get zero or negative value. Must always be positive. Multiplying or divide. Right? P is the product of A times B. Q is the quotient of A divided by B. So each of them, P will have a fractional error or proportional error. Delta Q will have a proportional error. A will have its proportional error. B will have its proportional error. And then you add them up. Memorize it. Or you can times 100 here, times 100 here, times 100 here. You will get percentage in P or percentage in Q equals to percentage in A and percentage in B. Or we add the fractional error or percentage error. Okay, so if you sum, we just take delta S, delta A, delta B.
Hai ăn về. Hai ăn đi. Money.
A minus B, delta A,
Hậu chạy.
delta A plus delta B.
Mày vượt gì đó.
Or, right, we multiply quantity. Area is L, length times breadth. Each will have its proportional error. And we add them up.
Nó sẽ bắt đi vui như thế.
Okay. Ice cream.
Okay, so each of them have its proportion error.
Put inside fridge, right?
That's 100% and 100%. That's what it means, right? Either you add the proportion error or you add the percentage error. Okay, where you multiply, we add the proportional error. But if it's power L squared, delta A over A, okay? Delta L over L plus delta L over L is 2 delta L over L. Right? So power, we take this 2 down, and then L is delta L over L. Same. Right? Each of this one will have delta A over A, delta A over A, delta A over A. Right? This for y equals A cubed. So we add them up is 3 delta A over A. So that 3 comes here. And that A becomes delta A over A. Right? Or we can use 3 times percentage delta A. Right? So it's 2 to A to the power of n, the same. N come down here, A becomes delta A over A, Y becomes delta Y over L. Y. Or percentage delta Y equals to n times percentage delta A. Right? This one is for, you can use this method in all your calculation if you don't want to memorize the rule. But you need to know this one for A2. AS don't need to know function. But you can use the method. Right? That can be the function. It can be this one example or that one there. Then you have X, Y. So that can be X with the X as its uncertainty plus delta X. So that will give you your Y max. Right? You put this value into here, replace the X, then you get this value. So that is called your delta Y. Right? Or you can use this value, X minus delta X, Y min. So Y max is Y plus delta Y, or delta Y, take this over, that's all. You can use this method. Largest value minus average value. Right? Or average value minus the smallest value. Right? Example. Right? I will go at this one. That's it. Quantity X, 30 plus minus 1. So you find your Y first. Right? Usually should be two significant figure. Then find the largest value, 30 plus 1. So sign 51. 0.515. So subtract. Subtract these two values. Get your 0.015. So remember that one should be one significant figure. So these two decimal place is also two decimal place. Right? Have a go at this one. Suppose a student measures the length L equals 20.0 plus or minus 0.1. Find the proportion error. So we take your uncertainty divided by 20 as proportion error. Percentage error, we multiply by 100. If I multiply by 100. Right? Have a go. This 10 is 20. So each of these is 20. The smallest variation is 20. Sorry, not 20, 2 cm. This is 10 is 20. So this is 10. So 10 divided by 5 is 2. 2, 12, 14, 16, 18. So 2 cm cubed. Uncertainty is divided by 2. So this is the first reading. 20 plus minus 1. And second reading, you put a stone inside there. Water level rise up. So 230, 32, 34, 36, 236. Oh, kurang. Come. So subtract, you get 216 plus minus 2 cm cube. Right? Testing your understanding, identify. Right? There's your S value, there's your measurement, there's uncertainty. So this one is trying to get you to know your symbol. This is your S, this is your delta S, delta S, this is your S. Right? So delta S is 0.2. Delta S over S is proportional error, 0.2 divided by 10. Percentage, you just times 100. Right? Delta S over S times 100. Okay, so your S has this value, and your X equals to S plus B. You add the two quantity, B has 20 plus minus 0.3. So uncertainty in B, you should be able to tell me 0.3 cm. Percentage, times 100%, 1.5%. Right? Absolute error in X, one. You just add these two together, add the error when we take the sum. Okay, so it's 0.2, 0.3, 0.5 cm. Okay. Delta B, we have already calculated. Right? That's your delta X. Right? Delta B. So you want to get our calculator there. A and C. Percentage delta X. Right? So X is S plus B. 20 plus 10. 30. The percentage is just your 0.5. That's your X. Sorry, that's your delta X over X. 1.7 cm. Okay, so we'll stop here. We will continue our lesson in the next video.